Thank you for coming back to our channel, The Physics Mindset. Now, today, you can't call yourself an electrician, a solar professional, electronic technician, and an engineer without knowing electrical units. Which we are going to study today is electrical units. Electrical units, these are the terms we use every day. If you enter the field of electrical, you will always talk about electrical units. Always in life. Wherever you go, wherever you're going to do some short circuit troubleshooting, wherever you're going to repair some electronic gadgets, whichever installations, either solar installations, electrical installations, you're going to use these electrical units. This is the most important concept in the fundamentals of electrical engineering. In engineering, we use these terms. We normally, when calculating some things, when you want to buy some things, you will end up using these terms. Okay? Let's say you want to buy a machine or a bulb. You will still ask, what are the watts of the bulb? Watts are the unit. A unit, an electrical unit is, let me short it for you so that you understand it very fast. Electrical unit, it is the same as the SI unit. SI unit is the international standard unit of an electrical charge or an electrical instrument. Okay? Now, the international standard unit of voltage is what? Is volts. Okay? The SI unit of power is what? Is watts. Okay? And that is the unit we are talking about. Okay? Today, let us jump into some of the electrical units we are going to study. Never ignore this topic because you need to use it every day. When you're going to buy a battery, you will go and ask, what is the ampere hours? Amperes are current. It is a unit of current. You see how you're talking about units? Ampere hours. Or when you're going to buy your TV, you can ask, which voltage is this TV going to work on? Volts. Okay? You need to know the volts. That is the SI unit of voltage. Okay? They will tell you either 12 volts or 240 volts or 230 volts. Okay? What are the Hz? The frequency of this machine which you're going to buy. Frequency is the speed or the time AC, alternative current, changes. Okay? Now let us jump into our electrical units. I'm going to give you 10 of them, electrical units, which you are going to use in your day-to-day life in electrical engineering. Let's jump into one of them is the voltage. Voltage, its electrical unit is the volts. Voltage is measured in volts. The unit, we mean the measurement of that product in electrical. Now, voltage, let's call voltage to be a product. Okay? Voltage is measured in volts, which is represented by V. Okay? Now, let me give you a brief definition of the voltage. Voltage is the electrical pressure that pushes current in a conductor. Is the electrical pressure that pushes current in a conductor. Current moves through the conductor because there is something which is pushing it. Okay? And which something, the product is the voltage, is the electrical pressure that pushes current to pass or to flow through a conductor or through a cable or through a wire. Okay? Current doesn't just move alone. There is some Someone's helping it to move from one place to another. Current is the electrons. Okay? And that is our voltage. Today we are looking at the electrical units. 10 of them. Next, we are seeing the current. The current is measured in amperes. Amperes, represented by A. Amps. Current. Check this. Current, voltage. Let's simplify with water principle. Voltage is like the water pressure. Water needs pressure to move in the pipes. Okay? Now, also voltage, also current need pressure to move through the cables. Now, current, since we have seen that voltage is the pressure which pushes current to flow through the cable. Okay? Now, current, take current to be the water, because pressure pushes the water. Okay, water pressure, that's the principle. Water pressure pushes the water, then water will pass through the cable. If this is our container with water, and this is our pipe, okay, we apply pressure, water pressure. This water pressure is technically, electrically, call it the voltage. The voltage is the one which pushes water, then water will flow through the pipe. Okay, now technically or electrically, take this water to be the current. Current needs voltage to flow through the cable. The pipe, take it to be the cable. Because we have the principles. Our principle in electrical, the way they do the pipe work of the water in an installation is the same way we do the pipe work of electrical in an installation. We have the same principles. Okay? In common, we have the same principles. Though for us we use voltage and current to pass through the cable, for them, they use water to pass through the pipes. Okay? Sometimes when you are using the conduits, we use our cables to pass through the conduits. And for them, they use water to pass through the conduits. Okay? Now, this is the current which is flowing. Current is the water flowing. Now, current is the flow of electricity. Current is the flow of electricity or the flow of electrons. Now, the flow of electrons, it depends on which speed, which pressure, how many voltage are applied to push the current, okay, in a conductor or in a cable. That's why we shall see high voltage. Once you see high voltage, just know there is also high current, because when the voltage is high, meaning current also is moving at a high speed. Whereby, once you get a shock, when there is a high voltage, current is the one which passes through you, pushed by the voltage, and it shocks you. High voltage, high currents. You check this. Sometimes a battery, you can measure a battery with 12 volts. But when it has low current. Why? Sometimes a battery can have voltage without current. That's why sometimes you measure a battery, it has 12 volts, but it is not working. It is not lighting our system. Let's say solar system. If you didn't charge, okay, you didn't put currents inside. When you are charging, we sometimes increase current and voltages. Sometimes voltage can appear, but current may not be there. Those are two other things, okay? But always when there is voltage, there is current. But current is not that too much. Always current is less than the voltage. Pressure is the one which is higher than the current. You can see even the formula. You now want to give you just something. Technically, you understand the things. Check on this formula. If you want to know the current of your house, or the current which goes in a TV. Okay, we can do it together and we see how we can calculate this current. Let me give you a simple formula to calculate current in your household. You can know the current. That's why I'm telling you, current moves small in our installations. That's why one of my subscribers asked that what is the effect of resistance? What is the effect of the cable in when there is resistance in it to the light? What is the effect on the light? The effect on the light is when, let's say, when you're using a big cable. I remember I explained, just this a point to explain my colleague, my subscriber. He said, I told you the effect of the resistance in the cable, it affects the light. Okay? When there is a small cable, current will flow through it, fighting to reach where the bulb is. Okay? Now, this cable is 1.5 millimeter, which is calculated. Okay? Now, what if, and this bulb, our electrical bulb, we say the lighting circuit uses 1.5 millimeter, not more than that. For a proper engineering cable sizing, okay, it is 1.5, not more than that. But even though you use 2.5, your bulb will work. If you use 3 millimeter, 4 millimeter, 6 millimeter, let us say, if you are using a 6 millimeter, and this is the bulb, you switch on, electrons will come in big number. Here, electrons are fighting to pass through the cable in 1.5, because we are using also a circuit breaker. Let's say a circuit breaker of 10 amps. Do you know why they use a circuit breaker of 10 amps? That's why I'm going to give you how you can calculate anything, the current, if you want to find why they use 10 amps. That is very big ampere. Just small explaining about the current. This is a very big ampere. 10 amps on a lighting circuit is very big. Okay? Unless when you have installed a lot of lights on a 10 amp, very many lights. But I'm going to show you the amps which pass through the cable, which goes to the bulb. Very small, even it may be less than even 1 ampere on our one bulb. Okay? Now, if you have used a very big cable, these electrons have space in the cable. Once they have space in the cable, they will go direct. They will move in a very big number, current. Yet our bulb can handle a limited electrons, but they will come in a very big number. That's why I told you an effect. Though there is some resistance in the cable, resistance will be there, but if the cable is big, it means the resistance is going to reduce, because very many electrons are going to have space to move freely. Once they move freely, they will move with high speed. And once they come with the high speed, they will knock. The moment they switch on, they knock the bulb may blow. That's why our bulb blows. Electronic bulbs, these energy savers, they have electronic board inside. You will find when the capacitor has busted, or a transistor or a resistor has been burnt. Because of these electrons are moving in a big cable, they are very free, they are coming with the force of the voltage, they are coming very, very, very straight and fast. Reaching your bulb, they will hit the bulb once and the bulb will blow. And that's why we find our bulbs blowing. Because of currents being free in the cable, and because we have sized the 10 amps. Very many you might connect a lot of current. This is, I was giving you the difference. Meaning here, let's say you are using 6 millimeter on the bulb. It can work, but with the time it will blow. Okay, that is the effect which affects the light, the effect in the cable, in a resistance. When the cable is small, these electrons are going to fidget. They are knocking. The moment of knocking each other, they are reducing on the speed of flowing. Once they reach the bulb, they are already tired. And the bulb will work frequently very well. And this is the calculated cable to leave these electrons to fight. Once they reach the bulb, they are tired. But they reach the bulb, and our bulb will give us light. Once we use a very big cable, these electrons in 10 amps, there will be no obstacle, no fighting with each other to reach the destination. They will come very fast with a high speed, and they will blow our bulbs. That is the effect. Let me show you the example, because these currents are not very much. Let me give you one of the most important formula to use when you're calculating for currents. Okay? Never forget, engineers, if you have any time, you can calculate a current which is moving in your bulb, the current which is moving in your TV, and you know. Okay? Let us say our bulb, we use a circuit breaker of 10 amps. Okay? Now, there is a formula of power equals voltage times current. Okay? This is the simplest formula to use when you're calculating current. You know the voltage, or you go and buy a bulb. This is your bulb. Let us say a bulb of how many? We use okay, let us use a very big watts. I want to show you how you calculate for current. A very big watt, let us say a 100 watt. Energy savers normally use let's say 75 watts. Okay, now watts, power in watts. This bulb, okay, it is 75 watts. Okay, do you know that you can know the current passing through this light? And you want to design a circuit breaker. That's why we put a 10 ampere. 10 ampere is big. I'm going to show you how big it is. Now, check the formula. The voltage which passes through our AC voltage is always 240 in our houses, or 220, but normally 240. We use this formula to calculate. You know the power. Power is 75, but in the formula, power is voltage times current, whereby current will be equals to power divided by voltage, whereby power is in wattage, 75. You get your 75, okay? Divide by the voltage, which is 240, the voltage which is passing through. 240 in our houses. What is the current now? You calculate. You're going to see the current. Okay? Simply get your calc. Then use a calculator. 75 divided by 240. It will give us 0.3. 0.3 amps. That is the current passing through our bulb. 0.3. It is more less than even an amp. It is in a milliamps. This is milliamps, not ampere. In fact, it must be in mils because it is less than 1 milliamps. So you will check your chargers. Always read behind them the technical information. Always amperes are in mils because they are less than 1. When an ampere is less than 1, it is measured in milliamperes. Once it is 1 and above, it is an ampere. That's when we calculate an ampere. When it is less, mil. And this is the simplest formula. If you have your TV, go back behind it, check the rating, and you will see the power. Then you know the voltage is 240. Catch it for the current. If you want to calculate for the power it is consuming, okay, you can check. Use this formula, power, then go to the formula. Check the resistance. If there is a resistance, you can use voltage squared divided by resistance. That is the formula of finding power. You can know your TV, how much power it consumes. Anything, the formulas, we have them. I've given you all the formulas. Okay, electrical, we move with the formulas. Just I was giving you a simple formula. We go back on our electrical units. Okay, let's go back on our electrical units. We saw the current, that it is the flow of electricity in the cable. Once it is flowing, voltage is pushing it. Voltage is the electrical pressure that pushes current in the cable. Number 3, we have the resistance. Resistance to oppose the flow of current is measured in ohms. And an ohm with a symbol like this. Ohms is measured, the resistance is measured in ohms. The SI unit of resistance is the ohms. Okay, we can see the definition. Resistance is anything that opposes, opposes the flow of current. Current is coming, but anything that opposes the flow of current, that is the resistance in a cable. Meaning a cable itself has resistance in it, which we can't see, but we can measure it by using the Ohm's law. Okay? Whereby, if we are using the Ohm's law, voltage, let's say voltage equals IR, Ohm's law. Voltage equals IR. We can use this to calculate for resistance, whereby if you want to calculate resistance is equals to voltage over current. Use the Ohm's law because it is measured in ohms. Now if you want to calculate for resistance, we can use voltage divided by current. We have the current. I have shown you how you can calculate for the current using the power formula. If you have the resistance and the voltage, you can find the current, which is current will be equals to voltage divided by resistance. Okay? Now, resistance, since it is the opposition to the flow, not allowing, even though current will still pass through, but there is some opposition in the cable which opposes that flow of current. That's why cables create some small heat. That heat is caused by that opposition. Once you are fighting to pass through something, you sweat. But for the cables to sweat, they produce heat. Even as if you want to run and there is some opposition in the way, still you produce heat in the body and you will sweat eventually. That also happens in the cable. The resistance measured in ohms, that is its electrical unit. Now, we have another thing, power. Power is measured in watts. Whenever you're looking for something to buy, an electrical gadget, electronics, we buy them in power, which is measured in watts. That's why some people ask, for how many watts are that TV? You know the logic that you want to save some electrical bills, okay, or electrical energy from getting consumed. What is the watt of that bulb? You have a knowledge of the knowledge of electrical units. What is the wattage of my fan? What is the wattage of my washing machine? What is the wattage of my microwave? Some people don't know the wattage of these machines, but they have them inside the house. And once the electrical billing company brings you a bill of 100,000, you shake your head. But it is you. You didn't master the electrical units. You need to know these electrical units, and they will help you in your day-to-day lifestyle. Know the power, know the resistance, know the voltage, know the currents. Life will simplify when you're buying these electronic or electrical gadgets. Life moves on electrical gadgets. When people are buying phone chargers, I don't know what you look when you're buying for the phone chargers. The basic principle I can give you when you're buying a phone charger, look for its power, its watts. A phone charger, let's check the definition. Is a power is the rate at which electrical energy is used. That is number one. Or produced, at which electrical energy is produced. Used and produced are different things. Used, now let us say our microwave, it uses power. Okay, now if it is a 2000, this is, if our microwave is a 2000 watts, okay, it uses the rate at which electrical energy is used. Our TVs uses electrical power, electrical energy. Microwaves uses electrical energy. Our bulbs uses electrical. We are on used. The rate at which energy. This wattage shows you the rate at which your electricity is going to be consumed. Okay? Now, another thing, the rate at which your electrical energy is produced. Now that is when we go to buy the chargers, the phone chargers, okay? Or the laptop chargers. Check. We buy them in wattage. Producing. How many watts can be produced? Watts is the rate at which electrical energy is produced. If I want my phone to get fully charged very fast in a short time, I will buy a charger which is having a high currents. No, a high wattage. Okay? Watts helps us to determine that this charger is very fast. You see? Let me hope something is coming. And if the charger, let's say a charger is 5 amps. If the charger is 5 watts, not amps, okay? And yet other chargers are 1 amp, 1 watt. What if you see the charger of 5 amps? It indicates that it is the rate at which electrical energy is produced. The rate at which electrical energy is produced is at 5 watts. Now, a charger of using, meaning here on 5 watts, my phone will be full in short time. It implies when you come at 1 watt. 1 watt, the rate at which electrical energy is produced, like this. Meaning my phone will take long to be fully charged. Hope we are getting the differences, okay? That's why people run for high wattage because of electrical units. You know one of electrical units, even though you don't know all of them, but at least get like 5 of them. Know what wattage is. Know what resistance is. Know what current is. Know what voltage is, okay? This is number 4. Let us go and see the number 5. We are going on number 5. Number 5 is saying energy. Still on electrical units. I want you guys to know electrical units. Without knowing electrical units, it will disturb you in the fields. And these are the terms you're going to be using day to day. If you're a student, please master these electrical units. Okay? Electricians use these electrical units. Now, number 5 is energy. Energy. We have heard these words all over every day. Now, energy. Energy, its electrical unit or its international standard unit or SI unit is measured in watt hour. Measured in watt hour or kilowatt hour. This is the measurements these electrical companies use to measure our energies at home. Okay, at home they measure our energies in kilowatt hour. kWh. K means kilo, W stands for watt, H stands for hour. Okay, now check its definition. Energy is the total electricity used. The total electricity used over a given period of time. These electrical companies, they give us 30 days to use this electricity. Which gadgets use electricity? These are our TVs, microwaves, the fans, the DVDs, the radios, our charging radio phones, the lights inside our houses. Okay? All these things consume energy. For 30 days, these companies give us 30 days. After 30 days, they issue a billing receipt. A billing receipt which shows the electricity, the total electricity used over that period of time. The time, 30 days. Okay? Now if they bring for you, let's say, thousands, and you need to pay 100,000 of money in each country, in whichever country you are. Okay? Please, I told you, you need to know about the watts. Wattage is what consumes power or what produces power. Producing power, we saw that even inverters produce wattage. When we are designing an inverter, we design them according, we want to get the wattage they can produce, their output. Okay? And some electronic gadgets consume, but other electrical gadgets produce. So there are two things. Now another electrical unit is the frequency. Frequency. How frequently have you done something? Now, frequency is measured in hertz. You don't pronounce the T. Hertz. Hertz is Hz, representing by Hz. Frequency is the amount of times an AC electricity changes. The amount of time an AC electricity Hertz is not in a DC electricity. It is only found in an AC electricity. Now, the time an AC electricity changes, the times an AC electricity changes direction in every second. Hope you have got the definition. Check this. If this is our graph, it is small, but this is one turn, second turn, third turn, fourth. Now, the times this AC changes direction, it is what we call frequency. And it is measured. It's electrical unit. Always when you're measuring frequency, measured it in Hertz. Hz. And most AC electricity they use 50 Hz. It depends in which country you are, but always it is 50 Hz. Okay, it depends on which type of electricity you're using, but it is only found in AC, not in DC, because DC is in one direction, but AC, it changes direction, positive, negative, it changes neutral, it goes and it changes, it goes and comes back, neutral life. But for a DC, it goes, if it is positive, it is positive, it will never change to be a negative. If it is a negative, it is a negative, one direction, no changing direction. That is a DC. But AC will be, let's say AC, this is our bulb, power will go, this is our live, this is our neutral. Power will go into our bulb and it goes back to neutral and comes back again in our bulb and it goes back. It goes like this. Now this interval of moving, it is the graph. This is the graph which came in. Now the complete graph can be like this. You see, it goes, it comes back, it goes. They use the power, the neutral returns. That's why we call the neutral a return terminal or a return cable. That is a neutral. It brings back, then it takes back. Neutral comes, then it changes again into an AC, a live, I mean. Okay, in the transformer. If the transformer has two terminals, output, okay, this is our transformer. It has two terminals. You decide which is live. Let's say this is live, this is neutral. Now if we connect here our bulb on the live part type and our neutral on the terminal, you see how power will move again, it comes back. It will go round. That is AC. And it is measured in Hz. Now, the amount of time that electricity changes direction is called frequency. Another electrical unit, we have capacitance. Capacitance. Oh God. Capacitance is measured in farad. And the symbol for farad is F. When you're calculating for capacitance, always leave a unit, an electrical unit of a farad, which is F. Now, this is, check the definition, is the ability to store electrical charge. The ability, that ability to store electrical charge. Capacitance, remember something like, do you know capacitors there are capacitors in electronic boards which store charge, the ability to store electrical charge. Okay, those capacitors in electronics, they store electrical charge, and they are measured in not more than, it is less than a farad. Okay, microfarad. Okay, microfarads, these are like those big capacitors inside the electronic boards. In our TVs, they are found in our TVs, our phones, our radios. All electronic boards have capacitors. Our power supplies in our TVs, they use capacitors to smoothen the flow of current, to remove that staggered current so that it is smooth. Capacitors are very useful in electronics. We shall read there and we shall talk about the capacitors, then you understand well what a capacitor is in electronics. This is the ability to store electrical charge, but it is measured in farad. Okay? Now, another electrical unit is inductance. These are all electrical terms which I would like all electricians, all technicians, electronic technicians, solar professionals, you can't do things, you can't go and talk with a client without using these electrical units. When you're going to calculate for a solar panel, you will talk about the powers, that is the watts of the panel, and the voltage, that is the volts of the panel. That a panel is 100 watts, it produces a voltage of 12 volts or 21 volts. Okay, if you're going to talk about a battery, you're going to talk about the ampere hours, amperes, and the voltages, that is current. When you're going to talk about a charge controller, you're going to calculate it in amps, that is the current. You see how these electrical units are going to help us in dealing in a lot of fields in electrical department. When you're going to talk about anything, you will talk about electrical units, you like it or not. If you are an engineer, electrician, technician, solar professionals, electrical units are for you. Students, master these technical units. You will be the great engineers which you want tomorrow. Okay, now there is another electrical unit which is the inductance. Inductance is measured in Henry with a symbol of H. Inductance means, inductance is the ability of a coil, to resist the changes in current. It is like this: the ability to resist, how can I explain this to you? The ability to resist changes in current. If current is 10 amps, now the ability for this coil, not this 10 amps to change, so that they leave it the way it is, that this is 10 amps must be 10 amps. That ability is the inductance, and it is measured in Henry. The ability to resist changes in current, meaning current will remain the same. The current which is input may be the current output. That ability is the inductance of the coil. It is a coil. Let us say a coil, these motors, hope you know the motors and transformers. Transformers like this is a transformer. Now this coil, the ability to resist current changes. If current in input is 10 amps, we might need the same 10 amps in the output. But this resistance to limit, to stabilize this current, is the inductance. If you're measuring the inductance in a coil, we have said like in the motors and transformers, you will measure them in Henry. Henry, these names, they change the names, they give these electrical units according to the person who invented that electrical unit. Like Henry, like Faraday, like Volta. Okay, these are all scientists who founded those electrical units by doing some electrical experiments. Okay, let's continue and we see 9 and 10 so that we finish up. I told you I'm giving you 10 of electrical units which you will use in the field of electrical engineering. Let's see the other 2 ones which are remaining. Okay, now the 9th one, the 9th electrical unit is the charge. The charge is measured, its electrical unit or SI unit is measured in coulomb. Coulomb is simply C represents coulomb. Okay, now the definition is of the charge. A charge, an electric charge, is the amount of electricity stored. Amount of electricity stored or transferred. Amount of electricity stored, or if electricity transferred, it is electric charge and is measured in coulomb. Okay, now the last one is the conductance. An electrical unit is the conductance. The conductance is measured in Siemens. Siemens, S represents Siemens. Now, what is this conductance? Conductance is how easily electricity flow. How easily electricity flow. That is conductance. A conductor, conductance. A conductor, conductance. The flow of electricity. How easily electricity flow. It is how conductance electricity, or how easily electricity flow. Electrically, these are the words we need to use so that we sound like true engineers. How conductance the electricity. Remember, if the electricity really flows smoothly, this conductance is the opposite. This is the opposite of resistance. Resistance opposes. Some cable oppose the flow of current or electricity. And the conductance, if there is a good conductance, meaning the flow of electricity is too smooth. If there is less resistance, the flow of electricity is too smooth, and that is the conductance, which is measured in Siemens, represented by S, which is the opposite of resistance. Resistance is when there is high resistance in the cable and the opposition of the flow of electricity, that is resistance. But when there is no resistance with less resistance, or a material with less resistance, there we shall see some good conductance of electricity. Okay, and this is what we are going to end up with in our electrical units, or SI units, this international standard unit, which we use when you're doing any calculations. These are the units we use. We end with the figure. After finding the figure, you represent the unit. If it is you're calculating for current, represent amperes. If you get 10, put an 8 to represent an ampere. If you're calculating for a voltage, put V. If you get a 240, V representing volts. If you're calculating for resistance, put an ohm sign. If, let us say, if you're calculating for a 10 resistance, put an ohm sign to show that that is the unit, which is the measurement of resistance. Thank you for watching today's video. Let me see you in the next video about the electrical symbols. Symbols, since you know the electrical units, you need to understand also the symbols, because we're going to use these symbols when you're doing the electrical diagrams of electrical installations. When I'm going to install a switch, I'm going to install a socket, I'm going to install a bulb, I need these electrical symbols. Without knowing electrical symbols, a symbol of a main switch, because soon we are getting there. And I will be using the symbols, not writing. Once you see the symbol, just know this is a symbol for the switch, this is a symbol for the socket, this is a symbol for a two-gang, a symbol for a main switch, a symbol, okay, for an earthing, so that you know the great information in electrical engineering. Thank you for watching. See you in the next video. Subscribe, like, and share the video to your friends, family, fellow students, fellow electricians, so that they also have the knowledge you are gaining. Thank you. See you in the next video about electrical symbols. Don't miss.